Well, hey there, everybody. Today we're going to look at an analogy that I made to compare the behavior of particles in solids, liquids, and gases to a bunch of kindergartners stuck in their classroom. We're also going to use a different thing to represent heat and thus the kinetic energy that the kindergartners gain, or the particles gain, from that heat. So let's go ahead and get started. As you can see here, we have a bunch of kindergartners in their classroom. They got a nice little problem on the board they're working on. Motivational poster over here on the board. And you can see, as kindergartners will do, they're all set up in their nice little rows and columns, just like they would be in class. So they're in a nice little structure. They're not moving around, but like kindergartners tend to do, they're a little bit antsy, right? They shake, they shimmy, they vibrate, they move around a little bit in their desks. So that's kind of what they're doing. You can see they're moving around a little bit. They're kind of vibrating in this case, moving around a little bit, but they're not moving position relative to each other. They're just stuck in their spot on their little desks in this container, which we call the classroom. Just like solid particles are stuck together and they kind of vibrate back and forth. Now, let's say we wanted to add some heat to this, or in this case, what we're going to use is my new energy drink, which is legally protected and legally distinct from any other ones that you may know, you may have heard of, Pink Bison. Pink Bison is an energy drink that I'm going to use to represent heat, right? So when I add heat to a sample, I'm adding heat, I'm adding energy, and therefore, if I give some Pink Bison to all my little kindergartners, you get a sip, you get a sip, you get a little sip, you get a little sip, you get a sip, you get a sip, you all eat a little sip, they're going to get more energy. Okay, so when they get more energy, obviously they're going to start moving around more. So let's see what happens. Uh-oh. It started to get a little bit crazier in my class, right? You can see there's a lot less structure. They're not in nice little ordered rows and columns anymore. They're moving around a lot more. They're bouncing off of walls. They're moving past each other, moving through each other. They're exchanging positions. They're still contained. They're not like escaping, but you can see some of them are moving around a lot more, bouncing off the walls, providing a lot more energy. So this is what it would be like if these were a liquid. Obviously, you can tell my particles, or my kindergartners, have a lot more kinetic energy due to the heat that I applied to them through my Pink Bison. And so when I apply that heat, it adds kinetic energy to these little kindergartners and they start running around a whole lot more. Just like in a liquid, when you add heat, you're increasing the kinetic energy of those particles and they start moving around each other. There's a lot less structure. They can move around and pass each other. Now at this point, it would be a bit irresponsible to continue my analogy, so I'm going to stop here. But we can kind of imagine what would happen if we continue to. You can kind of continue to imagine. Like, wait, whoa, what are you doing? What are you doing? No, we're not going to do that. We can't do that. That's too much. So we can kind of imagine what would happen if we were to add more heat to a system. Take a liquid and you're going to add some heat to it. No. We already said we cannot do this. No. This would be irresponsible to do. You have to stop this. Stop it. Thank you. Okay. So like I said, if we added more heat to this, then we could, oh no, what are you doing? Oh, what have you done? Oh no. Now it's just, oh no, now it's chaos. Look what's happened. We've added even more kinetic energy. We've added more heat to this system. And now the kinetic energy, they've gotten even more kinetic energy. You got this guy has literally escaped the classroom. This one's going to float off into space. This one thinks he's Spider-Man. This one's hanging off our motivational poster. They've gone to a point where now the kindergartners are far apart. They've got tons of energy. They're running around. They're escaping the container. Okay. We've added so much energy. They've been to get away from each other and escape the container. And they move a lot faster and they are farther apart, so they can escape each other. And I kind of wanted to stop here. This is kind of where we're at. If we add enough energy, you get to a point where a gas, same thing would happen. If you were to take energy away, you would go back to a liquid and then finally a solid, like you would do if you're freezing water. Okay, so your next step is going to come up with an analogy kind of like this, but you're going to come up with your own analogy to help you remember what happens when you add heat to a system. Good luck.